Right, good morning, welcome. Yes, as the title says, JDK 9, 10, and 11, Pitfalls for the Unwary. Now, the idea of this presentation is to really try and distill into 50 minutes everything you need to know about migrating an application from JDK 8 or earlier to JDK 9 or later. So let's start with a show of hands. So who here is using JDK 8? Right, yes, that's exactly what I would expect to see. Who here is still using JDK 7? Okay, a couple of people. Anybody using JDK 6? Oh, yep, a couple of people as well. Anybody using anything earlier than JDK 6? Not seeing any hands. That's good. Okay, now let's try going the other way. Who in production is using JDK 9? Oh, okay, a couple of people. What about JDK 10? Oh, and JDK 11. Okay, oh, reasonable number of hands, JDK 11. Okay, interesting. So like I say, the idea here is that because majority of people are still using JDK 8, you're probably thinking about a switch to a newer version of the JDK at some point. So, as I said, the idea is to help you understand what things you might need to address in moving your application to a newer version. And really, one of the main reasons for this is that there is a big change in terms of JDK 9 and later. And that's because of some decisions that Oracle made about how they wanted to approach the development and the distribution of the JDK itself. Really what I'm talking about there is the fact that, well, the fact that we've got 3 versions in the last 18 months is different to what we've been used to. We've been used to waiting sort of 2, 3, even 4 years between major releases. But the other really big thing with JDK 9 was the decision that it was time to start tidying up the JDK. And I think this is a very good decision on the part of Oracle, because if you look at the history of Java, you know, it's 24 years old now, and up until JDK 9, we'd added lots of features to it, but we'd never removed anything. And that's great from the point of view of compatibility, but it does incur a significant technical debt. Right, let's get started then. Borrowed this slide from Oracle. They're very nice people. I can borrow some stuff from them occasionally. I used to work for them. And it lists out all of the features that went into JDK 9. And if you add them up, I think there's about 86 listed there. Some of them are very small, some of them are sort of medium-sized, and one of the 2 of them are fairly large. Obviously, with JDK 9, the biggest feature in terms of developers, in terms of deployment, and also from the point of view of compatibility and migrating your applications, is modularity. So I'm going to spend a couple of minutes talking about modularity. I'm not going to spend a lot of time talking about it, but it is an important thing, and it will have potential impact on moving applications to JDK 9 or later. So, as I said, compatibility has always been very important from the point of view of the Java ecosystem. And if you look at how we've moved through various versions, there were a couple of issues along the way in terms of JDK 1.4, JDK 5. If you look at JDK 1.4, we had the introduction of assertions. So assert became a keyword. We couldn't use that as a variable name. And in JDK 5, we had the introduction of enumerations. So enum became a reserved word, which meant we couldn't use that in our variable names either. But realistically, that was not a huge problem in terms of migrating applications. You could just simply do a search and replace, change your variable names, and it would compile. But on the whole, compatibility for Java has been very good. You can take code that's been compiled on JDK 1.1 and run it without recompiling it on JDK 8, with fair amount of probability that it'll work. The other thing is deprecation. So as I said, this idea that we've made lots of changes over time, and deprecation was introduced way back in JDK 1.1. That was a very good idea because it meant that we could have a way of understanding if there were parts of the API that we probably shouldn't be using. We should be switching to something else. So deprecation was introduced in JDK 1.1, and I actually did a little bit of research on this, and I found that there are 492 deprecated elements in JDK 8, and none of them have ever been removed. So that's, it's an interesting idea of having deprecation, but realistically, you should be using it to say, okay, we've deprecated this thing, now let's actually remove it. So the idea is now, with JDK 9 and later, deprecation is going to have a bit more meaning. And things are going to start being removed to make life easier for developers, make life easier for the open JDK people. Oracle have also been very good in terms of saying that they will give us warning about the fact that they're going to remove something. And so they've said that they will give us a minimum of 1 release warning for removal of a feature that's been deprecated, which I guess is very generous, because if they gave us less than 1 release warning, it would be no warning at all. So, okay, we do get a warning. And as I said, JDK 9 is about starting the cleanup of the Java platform, removing some of these older features, things that people really aren't using anymore. APIs, features being removed, and this process is continuing. So we've seen it in JDK 10, we've seen it in JDK 11, and it's going to carry on in the future. What this brings us to is a general statement about compatibility for our Java applications. And I took this from Mark Reinhold, chief architect of the OpenJDK, and he said, if your code only uses standard Java SE APIs, then it will most likely work without change. Now, that's a little less than reassuring. It would be nice if it said they will work without change, but no, it's most likely. And that is because, as I say, there are a number of changes in terms of different parts of the JDK itself that could affect compatibility, even if you're just using the standard Java SE APIs. And that's really what the rest of this presentation is about. OK, let's talk a little bit about the module system, as I said. So the first thing about the module system is, why did we need it? And again, if you look back into the history of the JDK, anybody here use JDK 1.0? A few hands, OK. So I can remember JDK 1.0 because that's basically when I started working for Sun Microsystems. And in JDK 1.0, there were 211 public classes that you could use in the library to develop your applications. If you move all the way forward to JDK 8, rt.jar contains about 4,500 public classes. Now, this is very good for us as developers because it means we don't have to write our own semaphore class, we don't have to write our own array list class. All of these things are provided for us. So we can just focus on, writing the application code that we need, and there's a rich set of functionality already available. Problem is that having 4,500 classes in one jar file is really not a very good idea. It's just become too unmanageable. And it's also not really very logical from the point of view that nobody in their right mind would actually write an application that used all 4,500 of those classes. I think it might be an interesting exercise to see if you could write an application that used all 4,500 of them, but it would be rather pointless. So the idea behind modularity is fundamentally to say, OK, let's take that big set of APIs and classes and break it up into more manageable pieces, which are called modules. Obviously, we already have a way of grouping functionality in Java. We've got classes that group methods and state. We've then got packages which group together like classes. Modules is taking it to the next level where we can group together packages and then divide up the libraries in that way. And there's many advantages to this because we can build a runtime system which only contains the modules that we need for our application. It makes it smaller. We can avoid problems in terms of minimizing the security surface or the attack surface that's available to people to try and attack our applications. So what the developers of the JDK did was they came up with, in the case of the OpenJDK, 75 modules. 27 of these are for the Java SE standard. Those are the things you actually need to call your thing Java. And then there are 48 which are JDK specific, and they cover all the other things which are outside of the Java SE bits of functionality. If you look at the Oracle JDK, at least for the Java 9 and 10, they have another 14 additional JDK modules. There are 8 for Java FX, and then there's 2 that are Oracle specific. So that's all good, and that's very simple from the point of view of migrating applications. The other thing that modularity gives us, which is a bit more of an issue that we need to address when we're migrating our application, is the desire of the OpenJDK developers to encapsulate the internal APIs. Because, again, rt.jar has 4,500 public classes, but it also has a number of classes in there which are there to make the public ones work. These internal ones, and Sun and then Oracle, have always been very specific about this, saying that you are not intended to use them as general developers. And the most famous or infamous of these is sunmisc unsafe. I like sunmisc unsafe because the clue is in the name. Unsafe. You're not supposed to use it. So again, let's have a quick show of hands here. Who has used sunmisc unsafe? Oh, okay, reasonable number of people here, few people. Okay, that's fine, because sunmisc unsafe gives you access to some functionality that you just can't get in normal Java libraries. You know, you can do things like fencing operations, you can do low-level atomic operations, some low-level memory access, things like that, which are very useful for performing high-performance code. So let me ask another question. Who here has ever used a third-party library or framework like Spring or Log4j, anything like that? Yes. OK, so you have used sunmisc unsafe. It's just that you don't know it. And this was the problem, because lots of people who write these frameworks and libraries have used sunmisc unsafe because of the fact that you can get better performance from it. So when Oracle said, we're going to encapsulate these APIs, which effectively makes them invisible, people said, oh, hang on, if you do that, it's going to break all our code. And it's also going to break the code of all the people who've used our code to write their applications. So we had some discussions about this in the Java SE expert group, and we talked to Oracle about this, and the decision was made that there would be ways of turning back on access. So there are some command line options for doing this. Now, if you want to migrate your application to using the module system, then you've got a number of ways of doing this. The first way is the simplest, which is simply to say, I shall leave all my classes that I use, my jar files, on the class path. And you can do that in JDK 9 and later, because the class path is still recognized, it still works. So you put everything on the class path just as you did before. You don't change the command line. And when you run that application, all the classes which are on the class path become part of what's called the unnamed module. So it works in terms of the module system. So the unnamed module depends on all modules on the module path, and the relationship between those works quite happily. So everything gets exported, the dependencies are there, and your application should just work. I say should because there are other things that might affect it. But from the point of view of leaving stuff on the class path, there's no issue with doing that. What you can then do is you can migrate gradually to using modules rather than classes on the class path. And you can do that by taking your jar files, you can move them unchanged to the module path, and that way they become what's called an automatic module. Automatic module, because it doesn't have any module information, will be named based on the name of the jar file. It will export all of the public elements that are available in the packages, and it will have a dependency on everything else that's on the module path. So it's an easier way of migrating without having to make too many changes. And then what you can do is you can actually do the full change, add the module info.java file to your jar file, and make it work that way. So if we look at that in terms of like a diagram, what you can see is that we've got the class path and we've got the module path. With our existing application, we leave things on the class path. That all becomes the unnamed module. We have dependencies on any jars which are on the module path. And then, as we want to, we can say, OK, let's take one of those jars. We move it onto the module path. And then the dependencies are automatically figured out for us. And if we want to then take the next step, we can add the module info.class file into there, and it becomes a full module. So this is a nice, smooth way of having a gradual migration between using class path and module path. In order to reverse the issues of encapsulation, there is this wonderfully named big kill switch for the command line. And again, the name of the flag is illegal access, which sounds quite impressive. Now, there are 4 parameters that you can specify with this. The first, which is the default at the moment, is permit. So if you don't specify anything, then permit is what you will get. When you run your application, if you refer to one of the internal APIs that you shouldn't have been using, whether it's through your code or through some library, then the first time that you use it, you will get a warning message printed on the console. If you want a bit more information about that, you can switch to warnings. And then what will happen is every time you use a particular API, not just the first time, you'll get a warning printed on the console. If you want even more information, you can go to debug, and debug will print out a warning every time you use it, and it will give you a stack trace to show you how you got to using that API from within your code. And that way you can trace back and you can say, okay, I need to go and change these things and use some other API if I can. At some point in the future, the idea is to turn off access to these internal APIs, and the default will become deny. Now, when that happens, I don't know. It's probably not going to be for a while yet. If you want to reverse encapsulation in a more specific way, because if you use the big kill switch, that's effectively overriding the access for the entire application. What you can also do is you can override the access in a more fine-grained way. And you can do that with one of 2 command line options. One is add exports, and that's if you want to just use the standard, import a package and then reference it from within your code. And you can do that in one of 2 ways. First is you can say add exports, and then you give the name of the module, in this case java.management. You give the name of the package that you want to be accessible, com.sun.jmx.remote.internal, and you can specify a specific module that you want it accessible to. So my test is a module. If you want all of the class path to have access to that, then you can simply say java.management, sun.management, all unnamed. And then everything on the class path will have access to that particular internal API. That's through exporting and importing packages. If you want reflective access, then you can use the add opens option. And again, you can do the same thing, add opens, java.base, java.util, all unnamed, so that you've got reflective access to all of the java.util libraries within the java.base module. Another way of doing this, especially if you're writing a library and you want to be able to provide that to somebody and not have them required to specify extra things on the command line, is you can put extra information in the jar manifest. So in the case of add exports, you put the information in the jar manifest, and that way the JVM, when it reads the jar file, will say, oh, okay, we need to make the Sun security provider available to the code in this jar file, and it will gain access. So it means you don't have to put extra things on the command line. If you want to find out about dependencies, so which modules you depend on in terms of your code, then there's this command called JDEPs, which is quite useful. And I have to say that if you look at JDEPs in JDK 9, it had some things it did which was a bit weird. But now they seem to have tidied that up, and in JDK 11, it works a lot better. So what you can do is you can say, OK, here's my application, and I run JDEPs on it. I say where the module path is, which module I want to actually examine and find out information about, and then it will give you a list of the things that you need for that application. So in this case, we've got java.base, we've got data transfer, we've got some things from desktop, logging, scripting, SQL, XML, and a few JDK ones as well. JDK unsupported, that's the Sun MISC unsafe things and stuff like that. And what that allows you to do is to say, OK, here's my jar file. These are the modules I need. And then if you wanted to, you could use JLink and build a runtime for your application. And the nice thing about that is, and I wrote a blog post about this, is you can still use JLink even if you haven't modularized your application. So you can take your existing jar files, run them all on the class path, but still use JLink to build a runtime specific for your application using this information. Missing modules. OK, so we said this idea of modules that only use Java SE should just work. And the reality is that in JDK 11, or in fact in JDK 9, so JDK 9, they started to remove the java.se.ee module. And the way they did that was by saying, well, we'll leave that module in there, but we'll turn it off in terms of default compilation, default runtime. The java.se.ee module is what's called an aggregator module, so it doesn't contain any packages directly, it just contains references to other modules. And if you look at what's in there, there are 6 modules. Corba. Anybody here using Corba? Nobody. Excellent. So there's Corba, there's the Beans activation framework, there's JAX-B, XML binding. Anybody using that? Yeah, a few hands. Okay, and this is the one that catches most people out. JAX-WS, so Java Web Services. Anybody using that? Yes, quite a few people using web services. These are SOAP-based web services rather than the more traditional way, or I say more traditional, the more common way of doing it with RESTful web services. But for JDK 9 and JDK 10, these have been, they're still there, but they don't get turned on by default for compilation or for runtime. If you want to use those modules in 9 or 10, then basically you've got an option to say, okay, you can add them from the command line, or you can go to Maven Central, you can get a version of it there, you can get a reference implementation from the relevant JSR, and so there are different ways of actually replacing these modules if you need them. Small incompatibilities in JDK 9. Okay, the first was that a single underscore became a keyword, a reserved word. Anybody use a single underscore as a variable name? No, okay, fine, that's good. Well, I did check, and if you're really dedicated to this, you can use 2 or more underscores as a variable name, and it will still work. But in JDK 9, if you have been using a single underscore as a variable name, it will give you an error. So that is something you might need to be aware of. Yep, like I say, 2 or more underscores will still work. Deleted deprecated methods. The first time we've actually removed some methods in the JDK. And they went really overboard here, and they removed 6 methods. And the 6, you've got to think to yourself, okay, so 6 methods they removed. What did these 6 methods do that was so bad that meant that they got removed? And ultimately, it's in Pack 200, Unpack 200, both of which are primarily used for applets, and the log manager. And there's 2 methods in each of those, add property change listener and remove property change listener. The reason they removed these 6 methods was because when they tried to separate out the rt.jar into all these modules, they found some odd connections between different pieces of code, and by removing these 6 methods, it made it a lot simpler for them to separate out the different modules that they wanted. They also removed a class, and this is not part of the Java SE standard, it's part of the Java Authentication and Authorization Service, and it's com.sun.security.auth.callback.dialog callback handler. Anybody think they've used that? Probably. Oh, no, maybe somebody did. Okay, so that was deprecated way back in JDK 7, so you should have been getting warning messages about that anyway. Again, a tool is available to help you find if you've used deprecated APIs, because if we're going to start seeing more of these removed, it's a good idea to check your code to find out what might be causing problems. So JDepreScan was introduced in JDK 9. It does a static analysis of class files or jar files. You don't have to run it on source code. You can run it on compiled code as well, and it will give you a report of things that you've used. I created a simple example here, and you can see that in this case it's used a deprecated class called RMI Security Manager. It's used some methods, get selected value in JList, and it's used a Boolean here. So it gives you the idea of which things you need to look at in terms of your code to figure out if you should be using alternative versions. The JDK and JRE directory structure has changed. The reason I'm highlighting this is because you may have written code where you depend on a particular file in the JDK being in a particular place. And so if you have, you might want to check the changes that have been made here. Before JDK 9, we had the concept of a separate Java runtime. So we had the JDK and the JRE. The directory structure looked like this. So we had the JDK, which had a bin directory, which had Java, Java-C, Java-H, and so on. We had a lib directory, which had tools.jar. And then we had a separate JRE directory. JRE directory had a bin directory, which had a Java in it. So we got 2 Javas for the price of 1. Had a lib directory, which had rt.jar in it, and so on. The idea behind that was that to deploy Java on a machine that wasn't going to be used for development, you could just use the JRE rather than the full JDK, and it would reduce the size of your download. In JDK 9, the concept is now about using modules, using JLink to build a runtime that is tailored to your application, and that removes a lot of the stuff that you don't need. It reduces the size of the runtime. So there is no concept now of the JRE in JDK 9 and later. Often I've seen comments on things like Reddit and Stack Overflow where people are asking, where's the JRE gone in JDK 11? And it has disappeared. So now it's just the JDK. And you've got flat directory structure, bin directory, conf directory, lib directory, jmods directory, and so on. So there's no more JRE directory, there's no more tools.jar, there's no more rt.jar. The version string format. Okay, so I looked into this, and it turns out we've had almost as many version string formats as we've had versions of Java. And again, if you use the version string in any way to parse information about the version of the JDK you're using, you might have to change your code. The problem we ended up with is if you went to Oracle's website and you downloaded Java SE 8 update 131, and then you ran Java minus version on that, what you'd actually get is 1.8.0_131. So it's kind of like, well, how is that related? And so now, you know, we also had to wonder which version had more patches in it. Was it 7 update 55 or 7 update 60? Logically, it would be 60, but it's actually 55 that has more patches in it than update 60. Don't ask me why. So now we have a new version string format, which hopefully is the last ever version string format for Java. In this case, we have feature, which is the big number, so that's 9, 10, 11. We have interim, which is always going to be 0. So, okay, if it's always going to be 0, why do we have it? But at least they've left it there for future upgrade compatibility. So at some point, they might decide to use it. But for now, it's always 0. Then we have update, which thankfully is logical in that it goes 1, 2, 3. Unlike in JDK 9, where it went 1, 4. Not quite sure about Oracle's way of counting, but now they figured out that 2 comes after 1 rather than 4. And then if they need to issue an emergency out-of-bounds patch, then there's another digit at the end that they can use to say it's 9.0, well, actually 10.0.1.1, and you've got a way of doing that. So it's much easier to understand. It's more semantic. You can parse it more easily. Non-programmatic issues. Again, if you were going to switch to JDK 9 or 10, then this is, from point of view of JNLP, if you're using Java Web Start and you've got JNLP files there, they're actually parsing them more strictly. That's actually such a small thing that I'm not going to talk about that anymore because, you know, Java Web Start's going away. One thing that could catch you out, though, is the removal of the extension mechanism and the endorsed standards override mechanism. These are things that are used primarily by things like app servers when they need to load extra classes as they launch the application. The one thing that has caught me out is that if you use JNI, sometimes you use the libext directory to put native libraries in. And if you create libext in the JDK 9 or later JDK directory structure, it will actually stop your JVM from starting. So you'll get a message that says libext exists, this is no longer used, and a fatal exception has occurred, your JVM doesn't start. So again, just something that you need to be aware of there. Lots of GC options have been removed. There's various combinations. This is all covered in JEP 173, so you can no longer use the incremental concurrent mark sweep version of CMS. There's various things like you can't use parallel new with serial old, which kind of makes sense because I don't know why anybody would do that. And so these things have all been removed now. Logging has also changed. And this is a little bit more important because they introduced a unified logging framework for the whole JVM. And as part of that, the logging of garbage collection messages switched to using the new unified logging system. So if you've got any tools that you've written where you're parsing log files generated by the GC logs, then you might need to look at if the format has changed, and you might need to change your code for that. And there's a lot of command line options that have changed related to this as well. Lots of flags have been removed. Now, I won't go through all of these, but these are ones which have been removed from JDK 9. And fortunately, if you use any of these, then basically the JVM will just give you a warning message saying, this option is no longer supported. I'm going to ignore it. So those ones, you can find the warning messages and then tidy up later. These are the ones which have changed. So things like printgc is no longer a valid option. It's replaced with -x log :gc and printgc details. These are the two that a lot of people do use. Then you've got to switch to using -x log :gc star. And as you can see, there's a whole range of other ones as well. I won't talk through these. If you'll get the slides later, so you can have a look and see if you've used any of these. The warning messages you get for these deprecated flags, either, if you're lucky, things like printgc, it will tell you it's deprecated and it's using the correct one instead. So you don't actually have to change your startup script. And some of them will give you a warning message again saying these things have been deprecated and that's all right. So you can just change things later on. Then there are non-starters. So actually in JDK 9, there are 50 command line flags from JDK 8 that have been removed and will actually prevent your JVM from starting. If you've got them in your startup script, you need to remove them in order to get your application to start. And this is things like print heap at GC, which again is one that I know quite a lot of people do use. There's also trace dynamic GC threads, and there's quite a few of these that will actually cause your JVM to not start when you try to run your application. Okay, so that's all the JDK 9 specific things. What about things that were introduced in JDK 10 that might affect our application? Right, local variable type inference, a nice new feature in the language. Java gets var. Java gets to look more like JavaScript. I'm not sure if that's a good thing or not. But interestingly, var is now a reserved type. So there is one thing that might catch you out if you have written code which I'm sure nobody here would have written. What does this imply? Well, it still means that you can use var as a variable name, which is very good. So you can do var, and that's fine. That will work. What you can't do, which you could have done in JDK 9, is create a class called var with a lowercase v. But like I say, nobody would have done that. So I'm sure we're safe on that. And because it's only the lowercase v version of var that is affected by this, you can still create, you can still create a class with a uppercase v var, and that will work. More things that have been deprecated have now been removed. So there's quite there's a few more actual things that have gone from the API. So the jdk.security.auth module, there's various things in there that have been removed. So the com.sun.security.auth package, there are 4 classes there. There's the policy file, the Solaris numeric group principal, the Solaris numeric user principal, and the X500 principal have been removed. Some of those do have options, replacement ones. They've all been deprecated. If you look at the documentation, you'll find that it tells you which thing you should use in place of those. And similarly with the com.sun security auth module package, there is Solaris login module and Solaris system that have been removed as well. So these fairly small changes that shouldn't affect a large number of people, I would expect. The Java Lang Security Manager has had some things removed. So the in-check field is gone. And then there are various methods that have been removed, like class depth, class loader depth, current class loader, current loaded class, get in check, in class loader. All of these things are gone. Again, they were deprecated, so you probably would have got warning messages if you were using these. If you're still using them and you try to migrate to JDK 10 or 11, they will stop your application from working. Java.lang.runtime. So this is something that's a bit more commonly used. There's 2 obsolete internationalization methods that have been removed. So get localized input stream and get localized output stream are both gone. Anybody think they've used those? No, didn't think so. A couple of miscellaneous things that have gone from JDK 10. The Java H tool has been removed. That's what you would have used if you were writing JNI code and used Java H to generate the header files that you need to integrate your native code with your Java code. That now has been replaced with a -H option on Java C, so it doesn't really make a huge difference. The policy tool has also been removed from JDK 10. More command line flags that have disappeared. So interestingly, because we kind of moved more to a 64-bit only version of the JDK, the -D32 and -D64 options are no longer valid. And again, they will stop your JVM from starting. There are also 5 -X options that have disappeared. Options on the JVM are very weird because you've got the -X and then the -XX options. Fortunately, we don't have many -XXX options. But these 5 options have disappeared. And I did look up some of these, and like the -X SQ no pause. I couldn't even figure out what that one did. So I don't think it's going to affect a lot of people. Bound threads, maybe people would have used that. Use alternative signals, again, that's sort of a very old thing, and maybe some people have used that. But essentially, they've disappeared. They might cause a problem if you've still got them in your startup script. Moving on to JDK 11. Obviously, with JDK 10 and JDK 11, the number of changes is a lot smaller than JDK 9, so we've got less things that we need to discuss. One of the big things is the fact that Oracle have made some changes around their distribution of Java. Now, in the past, we have gone to java.oracle.com, and we download the JDK from there. That's the Oracle JDK. As of JDK 9 and JDK 10, Oracle now produce 2 binary distributions. There is the Oracle JDK, and then there is the Oracle OpenJDK JDK. I have to say that very correctly because Mark Reinhold says that OpenJDK is an adjective, it's not a noun. So it's the Oracle OpenJDK JDK. And what that means is that we have 2 different distributions. As of JDK 11, the idea is to eliminate all functional differences between the Oracle JDK and OpenJDK. In the past, if you look at OpenJDK, it's the source code as the reference implementation of the Java SE specification. So it includes everything that you need to be called Java. It's actually a bit more than that because it has things like nashorn in it, which is not part of the Java SE spec. And the Oracle JDK has included other commercial features and some other things as well, which they provide as value add. What they've now done is say, OK, for JDK 11, we don't want to have any differences between the Oracle JDK and the OpenJDK source code, so functionally they will be exactly the same. This is something that has an impact if you're moving from JDK 8 to JDK 11. So the major things that have gone. First of those is JavaFX. Anybody using JavaFX? OK, well, a few people, good. JavaFX is really nice. I really like JavaFX. I've used it for a lot of things. This is not too much of a problem because Oracle have decided to separate JavaFX from their JDK. Doesn't really make too much of a difference because there's still the OpenJFX project under the larger OpenJDK project, and people like Gluon also provide binaries of this that you can download as modules, and they will work very easily. So it's really quite simple to replace JavaFX if you're still using it. Things that will cause problems, though, is the fact that the browser plugin has now been finally removed from the JDK. Anybody still using applets? OK, a couple of people, yeah. So yeah, applets basically have gone from Java as of JDK 11. And one of the things about this is that Oracle have decided not to open source the code for the browser plugin. So there is no simple way for anybody to provide that as an alternative. It's not like with some other things that were contributed as source code to OpenJDK, so we can just build those without any problem. Same thing applies for Java Web Start. Anybody using Java Web Start? Yeah, again, few people still using Java Web Start. I've definitely met some customers who are using that still for various older applications. Again, there's no simple solution for this. The code for WebStart hasn't been contributed to OpenJDK. There are some alternative projects which are a bit like WebStart, but they're not a simple drop-in replacement. So there's things like install4j, there's things like getdown, which do similar kind of things, but they're not a simple, okay, I can just take my code and drop it on there and it will work in exactly the same way. It's going to take some work to make those things do what you want them to do. A whole range of tools have been removed from the JDK and JDK 11. So because applets are gone, so applet viewer has gone, JControl has gone, all of the Corba-related tools are gone because the Corba module has disappeared. So IDLJ, OrbD, Servitool, tname serve has all gone. The Java Mission Control, even though that's been contributed as open source to the OpenJDK, they've separated it out so it's now a standalone package. The web services tools, because Java WS is gone, SchemaGen, WSGen, WS Import, XJC, all of those gone, and they've also decided to remove the deployment tools, Java Packager, and Java WS for WebStart. So all of these things disappeared from JDK 11. APIs. So I mentioned about the aggregator module java.se.ee. In 9 and 10, the module was still there. You just had to turn it on in order to use it. In JDK 11, that has been completely removed. It's gone. And then there are some other things that they've also removed in JDK 11. So JavaX security auth policy. Then there's some stuff around finalization, run finalizers on exit, some stuff to do with the security manager, and a couple of the thread methods have disappeared. So these might be ones that you want to check on. So thread.destroy, that has now gone, and thread.stop, but there's two overloaded versions of thread.stop. There's thread.stop that doesn't take any parameters, and then there's thread.stop that takes a throwable. The thread.stop, which doesn't take any parameters, is still there, but the one that takes a throwable has disappeared. I'm not quite sure why they removed one but not the other, but that was the decision they made. So if you've used thread.stop or thread.destroy, then you need to have a look at your code to see whether you need to do something with that. I mean, I'm pretty sure nobody here would have done that because these are they're marked in the documentation as being thread unsafe and you shouldn't use them, so probably you haven't used them. A few miscellaneous things gone from JDK 11. SNMP monitoring support was part of the Oracle JDK, wasn't part of the Open JDK. That's just been removed. So the JDK.SNMP module's gone, and the Java and JVM management MIB has been removed as well. A couple of minor things around the desktop. I did tell you I was going to tell you absolutely everything that might affect you. The T2K font rasterizer has been removed, and strangely, the Lucida fonts have been removed. So the idea now is that the JDK relies purely on fonts which are provided by the operating system underneath. There's no default fonts provided with the JDK itself. And then there's a number of certificates, security certificates for root certificates that have been removed from the trust store. This is really just tidying up some certificates that needed to be removed to prevent some problems. Like I said, command line options, I just did a summary here. So JDK 9 removed 187 -XX options. I think this is really impressive, that they could remove 187 options and basically nobody noticed. It shows you how many options there are. I think there's about 750, or there were 750. But having removed 187, they then added another 123. JDK 10, JDK 11 was a little bit more restrained, so they removed 36, added 26, removed 27, added 53. There's this great website. If you go to Chris Who Codes, and he's got this lovely web page that highlights all the differences between different versions of Java in terms of the different command lines. So it's a good place to find more information about these things. So just to conclude then, migrating to JDK 9, 10, or 11. So the simplest way to do this is to just leave everything alone. So just take your application and run it. Just use Java from JDK 11 rather than from JDK 8. Leave everything on the class path. You might have to fiddle around with some of the command line flags because, as we've seen, lots of them have been removed or changed or whatever. You may have to do some work around encapsulation because there may be some library code that you've used where the internal APIs still need to be accessed, so you might have to fiddle around with some of the command line options for that. And then there's a whole range of smaller things that might impact on your code depending on how you've written your code and what you've done with it. But at the end of the day, applications that work on JDK 8 should just work on JDK 11. One last thing I'll talk about very briefly is what we do at Azul. So we have this thing called Zulu Java as an alternative to other distributions of the OpenJDK. We take the OpenJDK source code, we build it, we run all of the TCK tests on it to make sure that it does conform to the Java SE specification, and we have wide support of not just platforms, but also versions. We actually go all the way back to JDK 6. We are still updating JDK 6, so if anybody wants updated versions of JDK 6, we can do that. 7, 8, 9, 10, and 11, and we have not just 64-bit versions of the popular platforms, but we also have 32-bit versions for Windows and Linux, and embedded versions for ARM32, 64-bit, and PowerPC. And you can download most of those there for free from our website. We also do a very reasonable support cost. With that, thank you very much. I've got a few minutes for questions, so yeah, thank you. One thing I would say is, remember there's the feedback on the app, so vote early and vote often.
Yes. Okay, any questions? Raise your hand.
No, stunned silence.
Yeah, it's lunch coming up.
Overloaded with information. Okay, I guess not.
Okay.
Okay.
Yeah, well, thank you then. And welcome back at 1 o'clock after lunch. Okay, thank you.